Hello and welcome to another one of D's ADD videos. Today we're going to be looking at partial fractions. What is partial fractions? Well, partial fractions is a way to decompose a fraction. What do I mean by that? Well, you once had a fraction and let's say you were able to factor it as I have done there. And you want to know what this fraction equaled as separate units before you found that common denominator. Well, partial fractions will allow you to do just that, find out what those question marks are. So the first thing that you will have to do in these things is factor that denominator. So if you're a little rusty in your factoring, go ahead and review the videos and handouts for that. This one, real quick, just a quick side note, if you factored by grouping, always look for that, especially if they're in even number terms or four terms like this. Factor out the x, you're left with x squared plus 1. Factor out the 2, you're left with the same thing. You're doing had over factor, that's x cubed over x to give you that. X over x to give you that. And factor out the x squared plus 1. And that's how you get that right there. So, what are you going to do? Well, how do you go about getting these separate entities? Well, you have to look for some general scenarios. These are some basic rules to look out for in your factored form of your denominator, and you will set up a general term or series of terms that are added together with unknown numerators, the a's, the b's, and you will solve for those doing the steps that I'm going to show you here in a second. So the first rule is going to be this one here, in which we're going to have a product of linear factors, and what you do here is you're going to add each term individually with a single letter in the numerator. The general rule is that the power difference for your x's should always be 1 between numerator and denominator for these. Okay, so if you look at the next rule here, because we have an x squared down here, then we have to have an x term in the numerator. I'm not sure what small plane decided to fly by right when I decided to record this video, but sorry about that noise. So here we have an ax plus b over x squared plus whatever the number is. Okay, and this rule here is the repeated root rule, and in the repeated root, what you're going to do is you're going to, for every power that is present, have a separate fraction. So I'm not sure why we went from a to c. I guess it's late, that's why. But you do a over the first power, it's understood to be a 1, and then b over the second power, and then you keep going c, d, until you get to whatever the final power is. Okay, and the last rule here is a combination of both this rule and this rule. And basically what happens here is you do a repeat of the ax plus b pattern for however many you have. So in this case, it would be ax plus b for the first power, cx plus d for the second power, and then it would be ex plus f, and then gx plus h, and so forth and so on until you get to the final power. Usually I haven't seen more than 2 of these, and the concept would be to break these factors down. So what are the steps? So the steps are as follows. 1. Factor denominator. 2. Separate according to the general scenarios. 3. Multiply both sides by the denominator of the left-hand side. Left-hand side. Okay? And every time you do that, your left side will only be left with the numerator intact. This is for the left side here. Left with numerator intact. And you're basically canceling it out. And all this will make sense if you watch the example video. Just right now, write the steps down. Try to, get the big picture. After you do that, you're going to multiply out the right-hand side. And group all like terms together. So we're going to group all the x squareds, the x's, the numbers, or x cubes if there are those as well. Okay. And then after you group them, you're going to factor out whatever common term they have, x squared or the x cubed. It's a common term. And then what you should have at this phase of it is something that looks like this. 2x squared. Let's use a different color here. Why is my eraser coloring and not erasing? Is the question. There we go. Let's see. Let's go with orange. So if I have 2x squared plus x plus 3. Actually, let's make it x to the fourth. So here on this side we have ax to the fourth plus b plus c x cubed, and then plus c minus b x plus d. Alright, so what you would do is the method of equating coefficients. Basically, if this equal sign right here has any validity to it, all the x to the fourth coefficients, in this case a, would equal 1. Because the x to the fourth coefficient must equal the x to the fourth coefficient. And then the next equation you could write is b plus c would equal 2. And then after that you could write c minus d equals 1. And d equals 3. And then finally you just back substitute your different expressions. So you would get c minus 3 equals 1, so c equals 4. And then if c equals 4, you can plug that into here. And b equals to -2. And once you figure out what all these numbers are, I just made these equations up, what you would do is you go back to your general equation that you set up at the very beginning when you separated according to the scenarios, and you would plug in those values and you would end up with a decomposed fraction. Like in this case, this problem should have given you, let's see if I remember correctly, I believe it's 2 over x squared plus 1 minus, I would imagine, right? I think it was x plus 2, 3, I would guess. I believe minus 2x squared plus 3. I'll do 2x, yeah, I believe that works out. Okay, so, and then after that, if you're in calculus or something like that, you can integrate these expressions, and these integrals should be much easier than the initial integral you were presented with. Okay? Alright, so the main key is knowing these scenarios backwards and forwards, go through them, rewind the tape, write them down, pause it, go through it, steps, factor, multiply. Remember, the left-hand side is always going to be equal to the numerator. In this case, this would all be left if you multiplied this on the, it's going to be the factored form, multiplied it on the right-hand side, then you'd have this equals, just watch the example video. It'll make more sense at that point. We'll have, stuff like that. So, and then B times something, C times something else. Alright? So I hope this has cleared up the confusion. You got to go through after that and do a lot of algebra, and you got to do a lot of factoring. Just take your time. It's tedious, but if you practice a few of these, you'll find out it's not as bad as it looks. It just takes a little bit of time. Thank you, and have a nice day.